In this video, we're going to go over the volume of composite images, and we're going to find the volume of those images. That basically means we're going to combine a variety of different images, like 3D images, and add them together. So the first one here says, find the volume of the cylinder attached to this rectangular prism and round the answer to the 10th. So we're going to find the volume of the cylinder first. So I'm going to do the volume of the cylinder, and that's going to be pi times r squared times our height, right? So r is right here, that's 4, so that's our r. And then this 4 is our height, okay, of the cylinder. So what we're going to do is we're going to multiply pi times 4 squared times another 4. That's going to give us 64 pi, and then we need to change that because it says round the answer to the 10th, and because the base is not round as well. So we're going to change that 64 pi to a decimal by multiplying 64 times pi in our calculators to 201.1, and that's feet cubed, right? Because it's three-dimensional. Then we're going to find the volume of our prism, okay? And that's going to be base times height, so that's going to be length times width times height. So our length, we could say length is 12, width is 6, 12, 6, and 14 is our height. So again, we're going to multiply those three things together, and when I did that, I got 1008. And again, that's feet cubed. So to get our final answer, we're just going to add those two things together, okay? So that's going to give us 1209.1 feet cubed. So that is the volume of the whole composite image, okay? So down here, go ahead and do this. You try number 1. Noticing that we have two separate prisms here, so you're going to find the volume of each and then add them together. So pause the video, come back to me when you're done. All right, so on this next one, I'm going to say the volume of the bottom prism. That's going to be length 18 times width, which is 8 times 4. Find the volume of all of that, and when I did that, I got 576. And this is millimeters squared. Then we're going to find the volume of the top one. And here we're going to multiply 5 times 5. And notice right here our width is 8, right? It's going to be the same as down here. Okay, see it? So that's going to be 200. Again, millimeters. Sorry, that should have been cubed. Cubed up there. So then we're going to add these together. And that's going to give us 776 millimeters cubed again, okay? So our next one says find the height of the cone, then find the volume of the composite figure. Write your answer in terms of pi. So if we're looking for the volume of our cone, again, our formula is going to be pi r squared times h divided by 3, right? Well, we have the radius. Can you see the radius right here? So the radius is, so we'll say r is equal to diameter divided by 2, right? So our radius is going to be equal to 5 because that's 10 divided by 2. However, we do not have the height, okay? So we need to find this right there, okay? We have the slant height, that's the 13, but that is not the height. So we have to find our height here. So to do that, we're going to put the 5 right there. See that right triangle? And this would be our C, correct? Because it's opposite the right angle, so that's our hypotenuse. So we're going to do h squared plus 5 squared, and C 13 squared is our hypotenuse, right? So h squared plus 25 is equal to 169. We're going to subtract 25 from both sides. That gives us h squared is equal to 144. Then we're going to take the square root of both sides here. So h is going to be equal to 12, right? Okay. So now we're just going to plug those values, our r and our h, into our formula. So this is going to be pi times 5 squared times our height, which is 12, okay? then we're going to divide all that by 3. So when we do that, I got 100 pi. And this is to give our answer in terms of pi. So we're going to leave the pi in the answer, okay? So this is, what was that? Meters? Yep, meters cubed, okay? Then we need to find the volume of our hemisphere, okay? So the volume of the hemisphere, I'm going to write hemi. That's equal to, if we were to find the volume of a sphere, it would be 4/3 pi r cubed. But here, because it's half of that, we're going to say 2 times pi times our radius, which again is 5 here. But we're going to cube it now. And that is the most common error. People forget and just square that. And then divide that by 3. So once again, we're going to leave pi in our answer. So when we do this, we do 2 times 5 cubed divided by 3. I got 83.33 pi meters cubed again. So now once again, we're going to add these two together. The 100 and the 83, and that's going to give us 183.33 pi meters cubed for our answer. All right, now this you try down here is going to be a test, guys, because we don't have the height of either of our, but it says the height of the smaller cone with a slant height of 15 is 5 inches. Gave us that one. Nice. Nice. I didn't even notice that. So this is 5 inches right here. And then it says, and the height of the larger cone is 9. Now we could have found these, guys, by doing our, because these are both right angles here, right? So this is 9 inches. We could have found both of those by, again, doing our right triangle, but they were nice and gave it to us in this problem. So, so the volume of our first cone, volume of, we'll say left cone, how about that? Is going to be, go ahead and find that, and the volume of the right cone, add them together, come back to me when you're done, okay? So this is going to be pi times our radius here, it says it's 12, right? So 12 squared times our height, which is 5. We're going to divide all that by 3. And again, it tells us to give the answer in terms of pi, so we're not going to actually have to multiply that. We just leave pi in our answer. So when I did that, I got 240 pi, and this time it's going to be inches cubed. Then we're going to find the volume of our right cone, okay? That's again going to be pi times our radius is the same, right? So it's going to be 12 squared again. And then our height this time is 9, and divide that by 3. So obviously that volume is going to be a little bit bigger than the other one was. So when I did this one, I got 432 pi inches cubed again. So once again, we got to add these two together to get the volume of the whole thing. So 2 and 0 is 2. We're going to pi in our answer. 4 and 3 is 7. 2 and 4 is 6. So 672 pi inches cubed. So our next one's a little more complicated. It says a cylinder with a 2 centimeter diameter. Well, first of all, I know if we have diameters equal to 2, then our radius is going to be equal to 1, right? So I'm going to go ahead and write that. Drilled through the triangular prism shown below, the triangular base has a height of 3.52. So height right here, h is equal to 3.52. And this would be our base, right? So we're going to need those to find the area of the base, because it's base times height, right? Isn't that how we find volume? So let's find the volume of our prism first. Okay, so we're going to find the base, which is 1/2, or we could say 7.1 times 3.52 divided by 2, right? Look at the formula for a triangle on you guys' formula sheet is 1/2 base times height, right? So, and then we're going to have to multiply that by our height, which is 14, okay? So you can do all that in your calculator. So when I did that, I got 174.9. Again, this is centimeters cubed. So that's our volume of our prism. Now we're going to have to find the volume of our cylinder, okay? So the volume of the cylinder is equal to our base is a circle, right? So that's going to be pi times r, which is 1 squared, times our height, which is 14. So, and this time we're going to have to multiply by pi, guys, okay? So, when I did that, I got 14 pi, and then I'm going to actually multiply that by pi. So that was 44 centimeters cubed. Now, this time we're going to subtract, okay? We're going to subtract that 44 from the 174. And when we do that, we get 130.9 centimeters cubed. So here again, if you have something that's removed, then you have to subtract it, okay? So let's see if you guys can do this one down here. Find the volume of the outer cylinder, and then find the volume of the inner cylinder and subtract the inner cylinder from the outer cylinder, okay? Pause the video and go ahead and do that. All right, so on this one, the volume of the inner, actually, let's do outer first. Let's do the volume of the outer. So that's going to be pi times our radius here is 10, yes? That's going to be 10 squared times our height. That's our height right there, right? Times 15. So, and it says also here, write our answer in terms of pi. So when we do this, the outer cylinder is going to be 1500 pi. And then our inner cylinder is going to be this one right here, right? So there's our radius for that one. So the volume of the inner cylinder, and that's equal to pi times our radius, this time is 5 squared, right? Times, again, our 15, okay? So that's going to be equal to 375 pi. And once again, what are we going to do with these? We're going to subtract them, right? We're going to subtract the inner from the outer. And when we do that, we get 1125 pi, and this is inches cubed, okay? Okay, here's another one for you guys to try. It says a sphere sits snugly in a foam cube so that the sphere touches each of the sides of the 18-inch cube. Find the volume of the foam to the nearest tenth. So we're talking about the foam minus the sphere, okay? Go ahead and do this and come back to me when you're done. All right, so I'm going to find the volume of the cube first. And to do that, remember, we just have to do length times width times height. So that's going to be 18 to the third power. And so that one was pretty easy. So that's 5832, and this is inches cubed. Then we're going to find the volume of our sphere. And to do that, we need our radius, right? So if that whole distance across there is 18, then what is half of it? It's going to be 9. So that's going to be our radius, right? So here we're going to do 4 times our pi times our 9 cubed. Don't forget it's cubed because it's a sphere, and divide that by 3. Now when you multiply all that, you're going to multiply by pi this time. That's going to be equal to 3053.6 inches cubed, right? Now what are we going to do with these two? We're going to subtract the sphere from the prism, or the cube. And when I did that, I got 2,778.4 inches cubed. All right, our last one down here. Example 4 says Paul's building a model space shuttle using a cone, a cylinder, and a hemisphere. What's the volume of the model space shuttle? So I'm going to extend this so I have a little more room to work. So we're going to find the volume of the cone at the top first, okay? So to find the volume of a cone, we need pi, we need the radius, we need the height, and we're going to divide all that by 3. So I have the radius, it's right there, that's the radius, but I don't have the height, so that means we have to find it, okay? So to find the height over here, right there, we need that height, don't we? We notice we have a right triangle again, so we have 5 squared, that's our hypotenuse, right, because it's opposite the right angle, is equal to 8 squared plus 3 squared, so that's 25. Is equal to 8 squared plus 9. Subtract 9 from both sides, so that gives me 16 is equal to 8 squared. Take the square root of both of those sides. So h is equal to 4. So now we know our height right here is 4, right? So now we can find the volume of that cone. So we're going to do pi times what is that? Pi times our radius, which is 3 squared, times our 4, which is our height. Divide all that by 3. So isn't that going to be 12 pi? It is. Okay. Then let's find the volume of our cylinder. So the volume of our cylinder is going to be equal to pi r squared h, right? So the only difference between it and the cone is we divide the cone by 3. So here we have, again, our radius is, so we're going to do pi times 3 squared times our height, which is 6. So that's going to be 9 times 6, that's 54 pi, right? And then the volume of our hemisphere, right, is the last one. So here we have our radius, again, that's 3. So we're going to do 4. Actually, let's do it this way. Let's do 2/3. Remember, 2/3 is half of 4/3. So we're going to do 2 times 3 cubed divided by 3. So if we divide that 3 cubed by 3, it's going to be 3 squared, right? So 2 times 9 is 18. So this is going to be 18 pi, all right? Now to find the volume of the whole thing, we're going to add them all together, aren't we? Indeed. So when we do that, we get 84 pi. And that's going to be inches cubed. Now, if we wanted to find out it in rounded, then we would just multiply by pi, okay? Now, the next question here says, Paul and Julie are having a disagreement. Julie says that if Paul doubles the height of the cylinder part of his space shuttle, he will have a larger volume than if he doubles the width of his model space shuttle. Paul thinks doubling the width will produce a larger volume. Do you agree with Julie or Paul? So let's just talk about what Julie says first. So Julie says doubling the height. So that would just be 2 times the height, right? So that would make it 2 times bigger, right? Now, when we talk about what Paul says, that's going to be the width, okay? So what does that mean? That means that 3, the radius, is going to double, right? So what do we do to the radius every time? We square it, don't we? Or we cube it. So it's going to be significantly bigger, and that's because we apply this to both terms. So that's going to be 4r squared, right? So that means this one's getting actually more than 4 times bigger because we're actually also cubing a bigger number. We would be cubing 6 instead of cubing 3. So it's going to be much bigger. It's going to be at least 4 times bigger, but it's going to really be bigger than that even. So our answer here is that it's Paul, and we just explained why.